In this video, we're going to take a look at problems 36 and 37 from Unit 3. We're going to combine our understanding of the counting rules and combinations, permutations with the concept of probability. So let's go ahead and take a look at this example we have right here from problem number 36. It says this: find the probability of getting 7 face cards. So that's king, queen, or jack. But we know that there's 4 suits. So there's actually 12 possible face cards within a deck of cards. And we're wanting to find the probability of getting 7 face cards when 7 cards are drawn from a deck without replacement. Okay? Now, we want to remember that probability is equal to what we want over what is possible. Okay, what we want over what is possible. I want to draw 7 cards and I want them all to be face cards. Okay, that's what I want. What is possible? Well, I could draw any random 7 cards out of the total 52 cards available to us. Okay? So what does this look like? What is the probability of 7 face cards? Well, we're going to use our understanding of combinations in order to solve this. Let's first focus on what I want. I specifically want to know how many different ways are there to arrange 7 face cards out of a possible 12 face cards, because that's what I want. I want 7 of those 12. But there's a whole bunch of different ways to arrange those 7 out of the 12. Well, and we have a formula for that. It's the combination formula. I'm going to write it as 12C7. I have 12 cards, and I want to know how many combinations of 7 of those 12s are possible. So that'll give me every single combination of 7 face cards out of 12 that are possible. That's what we want. But now we have to look at what is possible. Well, I'm actually selecting 7 cards out of a full deck of 52. So how many different combinations of 7 cards out of the total deck are actually possible? Again, writing this as another combination, I'm going to write it as 52C7. So I've got 52 cards, and I want to know how many combinations there are of 7 cards out of those 52. So to reiterate, what we're looking at is using combinations to get us the number of ways to get what we want. Well, the 7 face cards out of the 12 possible face cards that I could be drawing from, divided by what is actually possible, because we know that the deck contains more than face cards. We know that there's actually 52 total cards, and I want to know how many different ways are there to select 7 out of those 52. So when I do this calculation, I end up with P of 7 face cards, so probability of 7 face cards is equal to 792, that's the 12C7, all over, now here's a big number, 133,784,560. Now, if I work through simplifying this, I can actually reduce this fraction down to 99 over 16,723,070. So this would be the probability. As a decimal, that's a very small number, 0.000000 something. Okay, so the probability of me getting 7 face cards when I draw 7 cards out of a deck of cards is very, very small, very slim chance of occurring. Okay, so again, it's what we want divided by what is actually possible. So let's apply that same concept then to this next problem, problem number 37. Okay, selecting cards. So we have cards numbered 1 through 9, and they are shuffled and dealt face down. Okay, what is the probability that they are in order? round your answer to at least 8 decimal places. Okay, round your answer to at least 8 decimal places. So, again, we're going to apply that concept of the probability equals what we want all over what is possible. Okay, this one, to get those two values, we're not actually going to use combinations, but we are going to use another counting rule. So the probability here, what we want, I want all 9 of those numbered cards in order. Well, how many different ways are there to make sure that those cards are in order? Well, there's only one way. 1, 2, 3, 4, 5, 6, 7, 8, and 9. There is no other way to make sure that those cards are in order. So my numerator here is actually just a 1. Okay? So there's only one possible combination that satisfies what I'm looking for with all the cards in order 1 through 9. But the question now is, how many different ways are there to arrange these 9 cards? Well, one way to look at it, back from the section 2 out of chapter 4 here in unit 3, is to look at it from this perspective. 4, 5, 6, 7, 8, 9. I've got 9 spots to fill here with those 9 cards. If I randomly put a card down in that first slot, how many different cards are available? Well, I have 9 cards available for that first spot. Well, now that I've put one of the cards down there, how many cards do I have available to put in the next spot? Well, I only have 8 left. Well, you can see the pattern here. After I put those 2 cards down, I now only have 7 cards left. And then 6, 5, 4, 3, 2, and this last one, I only have 1 card left to put in that spot. So how do I figure out how many different ways there are to arrange those 9 cards? It's simply multiplying all of these values together. Another way to write this is simply 9 factorial. So how many different ways are there to arrange 9 cards? 9 factorial. So we're going to say now that the probability is 1 divided by, if I work out what 9 factorial is, that is 362,880. Then the problem says that we need to answer to at least 8 decimal places. So if I do that division, I find out that my probability is equal to 0.00000, make sure I'm getting all the zeros correct. There's 5 there, 2, 7, and then 6 by rounding it to that 8th decimal place. So the probability that I have 9 cards numbered 1 through 9 and I randomly set them down and they are all laid out in perfect order is very, very small. It's way less than 1%. The probability is 0.000000276. So again, the concept here is we're going to use those counting rules and combinations to figure out our numerator being what do we want, and the denominator being what is actually possible.